Hi, I'm Rylan, and today I'm sharing what I've learned and I guess what I've made off of this video by Andre Karpathy. Um, this was a great video to watch. I learned a lot from it, and if it wasn't evident from the title of it, it's about how to make the GPT tokenizer. Um, and so I'm going to go ahead and swap over to what I made for this. So this is a Google collab I made, and so we're gonna talk about what kind of each segment of this is and what it does. So, so this is just the text I'm using. It's more Shakespeare, like from last time. But for this segment here, this is initially converting it into a bunch of bytes, which is essentially just a number from 0 to 256. So that's how many bytes there are. And so it's making a list of all of them. It's just converting it all into a list of all these little tokens here. So, yeah. So I don't recall what the exact bytes for each of these, but we're converting it into bytes using an encoding method called UTF-8. This is part of Unicode. Yeah, and with those, you then have this function, which essentially gets the frequency of a bunch of bytes. So there's a bunch of bytes like AB, AB. It'll find those. It'll say how many times it occurs. That's what this is doing. It's getting the statistics of all the pairs. And then this function here, it merges two pairs into a new index. Because remember how these were up to, it doesn't, well, this is doing numbers exclusively, so technically it's numbers 0 to 255. It's a total of 256 numbers available to that. So it goes up to 255, but so this starts merging them into numbers that go above 255. So like the first merge we'll just say is AB and AB here. It'll merge it to be the new token 256. And so this is actually what goes through the list a certain number of times. So we have this is supposed to represent our total vocabulary size. So this would be on top of this would include the initial 256 bytes that were already given. And so this tells us the amount of times we'll have to merge to reach this vocab limit. So as you can see, it's at 256 again. So yeah, so you have this little thing here, which is called merges. So this is going to save this kind of identifier. So it's the 2 bytes that it's found, and the new byte it's being merged to. So what it'll do is it'll get the statistics of all of these, and it'll find the highest one with the highest frequency. So like which merge occurs the first, and that'll be the first pair to be merged. So it finds the most frequent pairs and merges them together. And as you can kind of see here, it starts putting it into And it saves this new index as 256 plus the current iteration, or the current merge it's at. So typically for loops like these, I will start at 0, which is why that 256 one is part of the new token set. Yeah, and so each time it does it, it'll print out like this. And as you can see here, would you look at that? We are saving all the new merges into this merges dictionary. And so for this little data set here is all the merges that it did. So it merged 44, 43, blah, blah, blah. I'm not going to actually go through all these, but you can see how it's each time the new thing it merges into is this next thing. And something interesting that starts happening, you can even see it here, is that it'll start merging the newly made tokens too, since those have a chance to actually occur more frequently than even some other types of merges. And so if you do this enough, you can have it will potentially have merged into words too. So if you do it enough times, it'll be able to find, hey, it's likely that it sees this set of bytes, which would be the bytes that make up an entire word. It'll be like, hey, these all happen consecutively a bunch, so we'll just slap them together into one thing. So that's kind of how most tokenizers work, like this. So this is printing out the now merged indexes. So here you have one for 287. And here you have 287 again, 286. And so we've kind of now made what's known as our merges list. So now what can be done with this is that it can be used to make a decoder and an encoder. So essentially what these will do is decoder, this is what will convert it back from these long strings of numbers into actual text. Yeah, so these were the indexes or the IDs that were produced from here and decoded back into the original text. So what this vocab does, I'm pretty sure, is it's converting the merges from these merge indexes back into, I think, the text. Yeah. Yeah. Okay. Yeah. It says it here. Or yeah, I'm the one that wrote this. Yeah. So with a given token, instead of it spitting out the indexes as merged, especially with these ones, it'll spit out the bytes that make that up. So if it's like, if you're given this 258 one here, which is made up of 257 and 144, it would include these ones in here. So it'd be 115, 105, 114. And so the code will then go through everything, all the indexes in the ID list, convert them into their original byte forms. Then it'll decode it from the UTF conversion. So it's just undoing the UTFs thing. That's what that's doing. Here, we printed it back out, which gives us this. And we have the encode, which more or less is just doing what we did here to quote-unquote train the model. It's running through the list after it has been turned into the numbers, or all of its bytes, and it'll run through all the given merges available and convert them into, and it'll slowly go through and merge everything back together. Or, yeah, it's going to go through all the possible merges and merge it together. So what I'm able to do is, based off of our initial training data, is I'm given this little segment here. I'm putting in this little segment here. Romeo, where art thou, Romeo? I, of course, did not capitalize those. Oops. But as you can see, it spits out this lovely string. Or string of numbers, which is representing this bit of text. And one last important bit that I didn't really mess with in this, but when showed off here, is something that OpenAI does with their text. So one of the things OpenAI does with their GPT models is they'll kind of separate out all the words into these punctuations. Or they'll separate it off based on punctuation. So as you can see here, you have kind of the commas by themselves. Or, oh, that was the wrong one. Oops. Yeah, you see the comma is by itself. Numbers are generally by themselves. The words, of course, are separated out too. And then, like, any of this like extra spacing, which is what's here, will kind of get thrown into one spot. So why they do this? So this is done so, like, punctuation, for example, isn't merged with letters. So sometimes what would happen is that something like this would get merged together, or something like this would get merged together during this training process up here. And so what this is doing is it's splitting it up so it isn't merging those together. So it keeps like stuff that we would know as distinctly separate from each other separated, when it may otherwise have put them all together. And so, yeah, that's more or less my entire program. This is a very simple setup, but it's something that I definitely do plan to put into my large language model from the previous video. So keep an eye out for once I have that finished. Thank you and have a good day.